Yes, sir. We can start, sir.
Yeah. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ತಮಗೆಲ್ಲರಿಗೂ ತಿಳಿದಿರುವಂತೆ ಇಂದು ಈ ಪ್ರತಿಭಾನ್ವೇಷಣೆ ವೆಬಿನಾರ್ ಸರಣಿಯಲ್ಲಿ ನಮ್ಮೊಂದಿಗೆ ಪದ್ಮಶ್ರೀ ಪುರಸ್ಕೃತ ಡಾಕ್ಟರ್ ವಿ ಪ್ರಕಾಶ್ ರವರು ರೋಲ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ ಮಾರ್ವೆಲ್ಸ್ ಇನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಫಿಸಿಕ್ಸ್ ಆಫ್ ಫುಡ್ ಎಂಬ ವಿಷಯದಲ್ಲಿ ತಮ್ಮ ಜ್ಞಾನವನ್ನು ಹಂಚಿಕೊಳ್ಳಲು ನಮ್ಮೊಂದಿಗಿದ್ದಾರೆ. Dr. Vishweshwaraya Prakash has done his entire education from University of Mysore. Currently, sir is an adjunct professor at Institute of Chemical Technology, Mumbai. Dr. Prakash sir served as president of International Union of Food Science and Technology during 2020 to 2022 and vice president of International Union of Nutritional Sciences during 2017 to 2022. He was the former director of CFTRI Mysuru and was appointed as distinguished scientist of CSIR. He was the founder member of KSTA and contributed immensely for the development of KSTA as a member for 2 terms. Recognizing his contribution to the field of science and technology in the state of Karnataka, KSTA Lifetime Achievement Award was conferred in 2011. He has received more than 66 national and international awards. He has received the prestigious Shanti Swarup Bhatnagar National Award for Science and Technology from Government of India and Karnataka Rajyotsava Award from Government of Karnataka. Also, several Lifetime Achievement Awards from various organizations like FICCI, International Union of Food Science and Technology, both in India and abroad, and AFSTI. He is also serving in the editorial board of number of food science, technology and nutrition and traditional medicinal journals. He was the chair of panel of nutraceuticals, which formulates the regulations for nutraceuticals for India, and served as member scientific committee of FSSAI, Government of India. He is the fellow of Royal Society of Chemistry, UK, IAFOST, Canada, and IFT, USA. He is also a fellow of KSTA and most of the other academies in India. Dr. Prakash sir's untiring and dedicated 52 years of service in the field of food science and technology and nutrition has resulted in 218 peer-reviewed research publications, 55 patents filed, nearly 30 PhD and master degrees, and 938 plus keynotes and convocation addresses. He is the author of 19 books and 12 more books are in pipeline. He is an editorial board of number of books globally. He has submitted more than 40 reports to the government in various capacities on policy matters. He is a visiting professor in the number of universities in India and abroad and continues to interface in many of social aspects of reaching out science to the people. He continues his academic activities even today in the teaching and training youngsters. Dr. Prakash has received one of the highest civilian award of the country, Padma Shri, for his outstanding scientific contribution to the nation. With this brief background, I request Dr. Prakash sir to deliver a lecture on role of chemistry marvels in understanding physics of food. Thank you very much, sir.
Thank you, Dr. Anand, and it's a wonderful days to remember. When we started KSTA, we were very hesitant, a handful of us under the direction of Dr. U.R. Rao, late Dr. U.R. Rao. KSTA was Karnataka State Technology, Science and Technology Academy. And there are many academies in India, so what will KSTA do? So it was a very different way it started, and today it reaches a large number, more than 5,000 to 8,000 people do switch on their talks whenever there is a talk. So this shows the way, the hard work of Mr. Anand, Mr. Umesh, and many of them in KSTA and the former president, the latest immediate past president, Dr. K. Ayyappan, and so on. So it's a great pleasure to share this platform with all of you. And it gives me also a great pleasure to see a large number of students, faculties, institution heads, vice chancellors, and many, many more. And more important to me, even some of the people who are not in the academia wants to know about food. And I see a large number of logging in. But in that, I see some 2-3 names with whom I studied, with whom I guided PhD, etc. I see and recognize Mr. Shyam Sundar, my student, my former senior colleague, Mr. Murali Krishna, and Dr. Jeevan Sidhu from USA. In the middle of the night, he has got up to hear the talk, and I had to be very careful what I speak because he is very knowledgeable globally. With that introduction, and a great pleasure to share the dais with all of you, perhaps in the next 35 to 40 minutes at the most, I would like to give major points in which you can think over. And this is especially so for teachers, I would like to say, because they are the perpetual knowledge donors. And these knowledge donors have to be recharged with new knowledge, like me. I keep learning, and today's question and answer session may be a great learning session for me. It's not a monologue, it's a multi-log, I would say, in this multi-dimensional and multilateral, multi-layered information technology of the globe. The topic is very, very different, and marvels of chemistry. And the other word is physics of food. Normally we say physics of matter, physics of the universe, astronomical object, and so on. Now with Chandrayaan, and also the many, many other things that are happening, we know how important physics is. And therefore, when we talk about physics of food, it fascinates some people. What is there in physics of food? We know how to eat food, we know how to cook food, we know how to grow the food, we know how to process the food to pickles, etc. at home. But what is there in the physics of food? So yes, that was my question 50 years back also. So that question gave me a large number of answers. Some of them I pursued, some of them my friends pursued, some of the other things my students are still pursuing, and I'm still encouraging people to pursue that, because that's something which is, according to me, in fact, much more complex than the solar system, because you are not dealing with one molecule, you are dealing with millions of molecules. So 9 planets we can handle, we can calculate, we can predict eclipses to the core into seconds, nanoseconds, milliseconds. But when it comes to food, physics of food is very complicated. But however, we have some tools of chemistry that can be used to understand the food structure in a different way. What I'm going to do is to break my talk into 3 minutes capsules of chemistry, then water, which is very important for all of us, and the food also, and animals. Number 3, interaction of water and plants, basically. That's very important. And food chemistry in general. Agriculture, of course, is very important. Without agriculture, there is no food. Even though the modern laboratories are threatening that they will have cell culture and give us food from the laboratory. So therefore, we need to address that also. Land to lifestyle and affordability of food. Then the industries, then the physics of processing of food, the physics of manufacturing of food. Without industry, there is no food. And we can't really eat paddy, we can't really eat wheat, we can't really eat anything raw that is coming out, like vegetables also. Packaging is very important. Shelf life and safety of food, it also occupies a very primordial position in this system, because without it, the food will get spoiled and you can't use it. And lastly, I will summarize in the last 2 minutes what I talked, typical of any teacher. And Anand introduced me with very, very affectionate words, but somehow I also missed the word. I happen to be a teacher also. So therefore, I'm as a teacher, we would like to go to the fundamentals and not assume that anybody knows anything. So let me start with the first point. Food is the largest industry in the world. Are you aware of it? 80% of the industries of the world is food industry. It's not automobile, it's not aeroplane, it's not aircraft. It is food industry. So this should fascinate the youngsters. Hey, why don't I start a food industry, or why don't I join a food industry? So therefore, we must realize that food is the biggest industry, from agriculture, from the land, with the farmer is also a participant, all the way to the consumer, and to the top of the Kargil top, or even on the top of the Kargil mountains, still food, the soldier requires food. So from farmer to the Sipai, I would call, they all require food, and we also require food. And that is the industry which is the largest industry. So if you want to become a food scientist, a food technologist, I think you are in the right track. Don't worry. Everything is not IT, BT. But I'm not degrading any other field, but you are in the right field if you are thinking in that direction. In that situation, we should talk a little bit about food epidemiology, like the wisdom we have over 6,000 years in India, another about 3,000 years from the southern Europe, and a large number of years of knowledge from Central America, Latin America, and in some of the colonies of the Midwest. These are all like 4,000 years old. So food has always occupied a major position wherever rivers are flowing. And in India, we have about 6,000 to 7,000 years of documentation of food. And that's very important. Therefore, the tradition of food, the culture of food, the epidemiology of food. Epidemiology is what happened when, who was eating what food, and how were they healthy or not healthy, and all the way down is all recorded in India. So therefore, it's only now recently in the last 150 years, we have stopped recording what food we are eating. Can you believe us? With all the IT, BT, and FT, we don't record what we eat. We means I'm talking of a system to maintain. And therefore, from generation to generation, a small food that was cooked 2,000 years back added more value as new processes, new techniques, a new hand that cooked the food. It was documented so well. And where is it documented? And it's all well documented, available on the website, is Charaka Samhita, Sushruta Samhita, which is much more medical, but Sushruta also tells that. I'm only focusing myself to India because that's the focus today. I can also tell you about Southeast Asia, China, and Midwest, and Central America like Mexico, and other countries are new countries. I'm not so worried at this point. Similarly, Nala's documentation of dishes, amazing, amazing what to add when to make a perfect dish. Bhava Prakasha, Madhava, Aharadikaranam, focused on food documentation, what was being eaten, how that got modified, and Bhojana Kutuhalam and Kshema Aharam. Ahara is food, Kshema is safe. So how do you eat a safe food? Added to that, from CFTRI, where I worked, Dr. K.T. Achaya has brought out the history of food, where he clearly mentions an example I'm giving. Idli came from Indonesia all the way to India and stabilized in the southern part of Karnataka, southern part of Andhra, northern part of Tamil Nadu, and the northern part of Kerala. And therefore, there are not one type of idli, there may be even 20, 30 types of different idlis. Not the size, but the composition, the way it is made. So therefore, every food has a history. Every food has got its own epidemiology. It has got its own genes to talk about it. And humans have tried to make it more convenient, more better. So these documents are available. So some of my talking will be on that, added to the modern science and modern tools that I have learned over my lifetime. Emerging and fusion and sandwiching of that is what I'm trying to do in the next 35 minutes. Food and agriculture are related. This is a very sad year because we lost Professor M.S. Swaminathan, who was also a well-wisher of KSTA quite a bit, and he has given a number of talks on KSTA platform. And what has happened in India is India, after independence, was begging for food with a begging bowl, and people were making fun of us because we had a large population and you can't grow enough food. And people like Professor Swaminathan and Professor Verghese Kurian in the dairy industry revolutionized the whole food industry in India. And today, we are not only self-sufficient, but also a net exporter. So therefore, it's very important that this agriculture has also fused into today Indian Council of Agriculture Research, which does a lot of research on land and is dissipating that knowledge to the farmers. And of course, everybody cannot grow everything. You can't grow basmati in Mysore and get the flavor. You get the rice, but no flavor. You grow the same basmati in Mukteshwar, in north, in the Himalayas, foothills. Fantastic flavor. So please remember, agriculture is soil in it. Without soil, no agriculture. And what soil, what crop is more important. And therefore, everything cannot be grown everywhere. And that becomes very important to realize that I can grow this and you can grow that and we can exchange. So that's what is happening. Let us review 1950, no food problems, just after independence. 1960, hopes that something will happen in science. Scientists will work, do something. Otherwise, we are begging for food. 1970, the first bell of good crop without monsoon also became a big history because of the many dams. 1980, M.S. Swaminathan definitely created the Green Revolution. And now it is Evergreen Revolution. 1985, Verghese Kurian made the white revolution of the milk, where the farmer got all the benefits in the cooperative. This was the first time a cooperative movement that took place, which was a 100% success. And even today, after nearly 28 years, India is number one in milk with 224 million tons as of last week. Unbelievable IPL, if I can call it for the cricket fans. It is very important how we have done that. And 1995 Grey Revolution banged on the doors with the sea and making sure that enough culture is there. 2000 Rainbow Revolution, government decided to make that, appropriated a lot of funds, and therefore we see fruit in every corner of every city, but affordability is still a question mark. 2010 Food and Health Revolution took place in India. And 2020 COVID food and immunity was talked. Everybody was an expert of nutrition and he would say, eat that, eat this, eat this. So it became a common knowledge. 225, 2 years from now, we need sustainable food. Therefore, in all, India has the leadership of food. India continues to have the leadership of food, provided we strategize it, we use the science, we use the modern tools, and make sure that we don't waste food. In fact, India is not the topmost country in wasting food, even though the West always tells developing and underdeveloped countries waste food. And I would like to correct to the audience, we don't waste food. We may have some losses because of natural disasters like flood and so on, but generally, we don't waste food. But in Western countries, the waste is very, very high. But again, to make that, I made a document for FAO where you can refer it. Those of you who want, I will send you a copy by email. It's very important to know how much food is wasted in the West and how much food is wasted in India. So therefore, we are very conservative. We are grown with difficulty. We are grown in joint family. Of course, with a lot of money going around with youngsters today, there may be a wastage. But generally, India doesn't waste food. Not even by storage, except a few here and there incidents highlighted by the media. But with that, we come to food culture, which is tradition, and more than 11,000 traditional foods in India is very, very vital. If India is broken into 80 different agricultural sectors and made sure the population, which is distinct, every 50 miles, you have a different kind of a basket of traditional foods. Many things you wouldn't even be able to pronounce if you travel 200 miles this way, that way. So we are a bowl of traditional foods, very rich in it, and each one of them are sustainable. If they have survived for 2,000 to 2,800 years, something must be positive there. So it should have gone by now. But I think in future, if we don't make a point to make sure it survives, we will be doing a wrong thing. Food and eating habits, I want to touch upon a little before I go into chemistry of foods. It's a sustainable practice, actually. You should make food eating a sustainable practice. I have a seminar at 3 o'clock, so I start eating at 2:45. I will finish eating in 3 minutes. That's not eating. So then, how to eat a food? And the example is millet. This is an international year of millet I want to give you. The way any doctor would represent millet is, you are diabetic, you are a borderline diabetic, have some millet with you. Normally they say finger millet is better than rice. But actually, if you go for chemical composition, there is not much difference between the two. The way you gelatinize the finger millet, the way you gelatinize the rice in cooking, there are two different patterns. So therefore, you gelatinize finger millet into a ball and make it a little bit difficult to digest, whereas rice is easily digestible. So your glucose peak goes up in the factual system of rice eating, let us say a bowl of rice. But on the other hand, you have two ragi balls, small ones. It will go release the ragi ball, will release it slowly. So you don't have a hyperglycemia immediately. So therefore, but everybody forgets the eating habits of ragi, how a farmer eats. You really have to make small balls and swallow it. You can't masticate it in the mouth because mouth has amylase. It will digest it and make it as good as rice by the time it reaches the stomach. So therefore, food habits, eating habits are very important to focus. And I just gave that example to you because many times we don't bother about the way a food has to be eaten. And therefore, it is very important eating habits dominate. Food processing comes to our rescue, and the role of physics there is very, very vital. Raw food put on the table, you can eat a few vegetables, a few fruits, and rest of it you can't eat. So therefore, somebody has to process it, which is industry in a large scale, convert it into value-added products. For example, we have primary processing from agriculture. That is cleaning it, winnowing it, making the paddy clean, and make sure that paddy goes to the processing center. The secondary processing there will make it rice, make it wheat flour, whatever you need, and the remaining straw goes to some other industry. The rice husk goes to somewhere. The wheat husk goes to a bread industry for including in fiber and so on. We come to tertiary industry where something is polished, something is made a gluten, a maida from wheat flour, and many, many others byproducts. But the quaternary industry is very interesting. When you take rice bran, the polish of brown rice, that brown rice polish contains tocopherol, tocotrienol, and it also contains oryzanol, an anti-cancer agent, and at the same time it has fiber, good amount of protein. All that is a huge industry by itself in quaternary processing. So that can add value to make sure that the industry survives into a high-level industry, a technology industry, which is dominated by physics and its engineering concept of heat, energy, carbon footprint. And at the same time, it also has the beautiful touch of chemistry in it. I can't remove too much of bran because I will be destroying the rice grains itself. If I remove less, then the lipase will act on it, and within 1 week, you have a rancid smell of rice. So I can't keep the rice in public distribution. So many people have asked me, why is it that rice is polished? I want brown rice. Yes, but you can't keep it too long. It becomes rancid. It has lipase 1 and lipase 2. And both of them will act and make it rancid. Are you ready to eat a rancid rice? No. So it has to be moderated by knowledge of chemistry. And the physics of the equipment has to make sure only you scrape a limited amount. And that requires high precision, like diamond cutting. Diamond cutting in Surat is highly respectable job. I and you cannot make it. I can tell you, polishing of rice is equally important. That is our day-to-day eating. We may buy 1 diamond in our lifetime, but we eat every grain of rice every day a diamond. So therefore, chemistry and physics combined in rice polishing is amazing, amazing. And therefore, we don't even know much about it. I don't have much time to tell. But I also want to move from quaternary to highly processed food, which today has become a vogue in the West that the more the processing, the better it is, easier to cook and so on and so forth, convenience, instant food, etc. But what is very important is we can't really overdo things and underestimate the individual capability. One may not have time, but one should make time to enjoy food, even cook food to a certain extent, if possible. Where instant food is very good innovation. And let me share with you to give the credit of instant food to CFTRI. Central Food Technological Research Institute, one of the pioneering institute in the Royal Campus, which was gifted to Government of India in 1950, October 21st. In 2025, it will have Platinum Jubilee. But what did it do in the instant food? Professor Kstacademy made instant rasam somewhere in the middle of 1950. Nobody knew what is this instant rasam. Take that powder, put it into hot water, you have ready-made rasam, not just chili powder. It constitutes everything. It was drum-dried at that time. So the concept was number one in the world first time. But today, how many instant foods in the world? Every time you touch an instant food, remember Professor Kstacademy and his big team in CFTRI. So therefore, why I'm telling this is highly processed food need not be also bad, but provided it keeps up the tradition, it keeps up the epidemiology, and keeps up that motherly touch and the grandmother touch in that wonderful food. If that is missing, then science, something is wrong. Science has to really come to the help and help us all. Lastly, extract beneficial molecules. For example, today we have turmeric. To extract curcumin from it for medical purposes is fine. But to eat the whole turmeric is more important without lead in it, because many a time lead is a contamination by many adulterants that are put. So we have actually to really look at safety. And that brings me to the chemistry of food composition. Most of the food is rich in water. And I don't know how many in the audience, I don't know how many are there. I might quickly have a view. And there are a large number of audience who would say that water is at least 60 to 70% of food, in some cases 20%. Water, as you know, is the highest molarity of any liquidator. In other words, 18 grams of water in 1 liter is 1 molar. We have 1000 grams of water in 1 liter, which is 55 molar. 55 molar is amazing concentration of water. So water is an universal solvent, and it's very important for life because it's 55 molar. It can change its structure notoriously. When you take a homeopathic medicine, the structure changes differently. For plant, from the roots, its structure changes differently. So water is a very notorious molecule, but at the same time, for food, water is important. If I remove water, I can keep the food longer. If I freeze the water, I can keep it longer. If I remove the water by toasting, roasting, I can keep it longer. So therefore, food composition should not vary when we dabble with water concentration in the food. But at the same time, if we remove water, it should be reconstitutable also. But when we look at many aspects of food, medicine, and also the Ayurveda and traditional medicine, which today composes of Ayurveda, which is a traditional Indian medicine, and yoga is also combined with it because of exercise, and Unani and Siddha and homeopathy. Why I'm giving this word is there's a ministry for this today in the government, central government. What is very important is we need to realize that food is not just what we eat. How much we can digest and make those molecules reach our body parts. And that depends upon how much exercise you do. You don't want the food to go to this tube and go to the other 2 tubes and go away. So that means the food is not stopping anywhere. You can't board the train. You can't board the bus. It just passes through. Maybe 5 to 10% is absorbed. But we want what in Sanskrit, the word pachana. Pachana is completely absorbing the nutrients of food in the body. And the remaining part as a fiber will go out, which is also very important. I'll come in the last portion of my talk. So therefore, the modern scientific tools of chemistry today can tell us what happens in the stomach, what happens in the small intestine, What happens in celiac disease, where the villi of small intestine is destroyed, the person becomes really resistant to absorb wheat products. So he can't eat wheat. So today, medical science, traditional wisdom, along with modern science and chemistry, with the background of physiology, the latest physiology of 2024 January, I'm talking 3 months ahead, very, very important. And that combination gives us physical measures many times. And that's what we do it in terms of making understand ourselves what food can do beyond what we eat in the esophagus. After the mouth, when it goes, what all happens is a mystery, total mystery of chemistry. And that mystery and marvel, we still are understanding, and we don't know how to really unveil that fully. Food and lifestyle and health are very important. I may eat the best food in the world, the most nutritious, the best food. But then my lifestyle is bad. I don't eat in time. I eat many, many foods which contains a large amount of salt, sugar, and oil. And therefore, very important is not only food, but lifestyle to make that chemistry inside our body work very well. If the lifestyle is bad, then whatever you eat cannot be converted into good nutrients and absorbed. So therefore, how and where, and I will give the example of already the eating habits of one food to the other. It's very important that food gets its importance in eating, at the same time to understand the composition of food, what contains the food contains, and also the combination of food. So the composition combination is a new technology that we need to understand, which our ancestors in the traditional food had a fantastic combination. Today, of course, new concepts are coming, new compositions are coming, new ingredients are coming, and therefore it is fascinating to mix each other and see what happens. And in that, there is also an element of pure air to be taken in. A lot of oxygen for its oxidation of food. We need to make sure that is taken, not short breaths, quickly short breath. We are always in a busy and a hurry system. Enough oxygen to go into the digestive system so that the food is well absorbed in the body after digestion, both in the stomach down into duodenum to in the small intestine, and in the large intestine dehydration take place of the food and exit. And therefore, how does this physical and chemical sciences goes into processes that into dynamics, what we call as process dynamics of food. Number one, the energy. The energy that the plant absorbs from the sun is what you get when you eat the food, right? The energy is important. It is concentrated in one form or the other. Mostly it is concentrated. Food is now so badly labeled. Everybody says it contains carbohydrate, proteins, fats, vitamins, and minerals. Mix all of them. I'll give you one bottle of each one of them. You make a food. You can't even go near it. So food is not just protein, carbohydrate, fats, vitamins, and minerals. It is something different, very different. And that's where the carbon footprint is very important, because the more number of good molecules in food, the more difficult it is to manage it, both in agriculture and elsewhere. Rice is supposed to be just carbohydrate, so don't eat it. A bad advice. The reason is rice consists of many other ingredients which are beneficial to your microbes in the stomach, which are good microbes. They are your inner body. They are your microbiota. They are very much understood today than elsewhere earlier. So therefore, it is also important to understand how the carbon footprint of food is going to work out very differently when you talk about one food like just a rice grain and how many ingredients it has as a result of its beautifully absorbing sun and manufacturing its own molecule from the nutrition of the soil and transmit itself into the seed. Actually, they're all not meant for you. They are for the plant to multiply itself. But what we do at the right time, we steal that and use it for us, and the plant gets its food to make that many seeds. So this is a very, very highly energy resourceful. And there are many attempts in 1950 to make synthetic rice. but we failed miserably. And today there is much more attempt to nutrition fortification. A lot of synthetic rice is being made in the shape of rice to add to the noon meal and so on, but not yet. But these are all new physics that has entered the physics engineering to make sure that you can use the knowledge in the right direction. Wasteful expenditure is another thing in the processing that is avoided very badly. Otherwise, it will not be sustainable industry. And byproduct utilization. As I already gave you example, when you mill the wheat, you actually peel each layer, and like in a typical modern wheat mill. And you also have an entollator which adds vitamins to it and makes the wheat flour, which is very nutritious, which are permitted additives can be added. But the point is, there is a rice wheat bran, there's also wheat germ, there are so many other byproducts that come out, and these are all utilized for a different purpose altogether to make different products. So it's not one wheat grain and one wheat flour, or one rice grain and rice flour, one sorghum grain and sorghum flour. Multiple co-products, byproducts. A huge exploration of universe is there in that. So therefore, when you look at byproduct and co-product utilization, it fascinates an engineer, it fascinates a technologist, and he really chases it or she chases it and makes sure more value addition is derived from it, so that the food system, which is sterile, which is like canning, freezing, ultraviolet radiation, or even high pressure processing today, or even microwave processing, and many other, pulse radiation, and so on and so forth. All these have come because of extensive investigations in physics, and that is applied to food. To understand the chemistry, mystery in that, and that is very important to understand how sterilization takes place under so many thousands of pascals of a very high valued commodity. And therefore, it is very vital that we should appreciate how technology is intervening and making it more better. I would now shift it to nutrition. The word nutrition was a little bit unknown for a long time. And it's almost now, from the time the first word nutrition was introduced, it's more than 120 years now. But even now, we are not fully aware what nutrition is. But in a way, COVID helped us to understand nutrition better. People respected food better. So when a neighbor asks, I think I have some signs of COVID, okay, eat this, eat that, have some ginger tea, and so on and so forth, eat some garlic. So whatever is that wisdom, maybe it is not proved by science, but not necessarily always science has to prove everything. Some knowledge of tradition is difficult to prove also, because they are by epidemiology. In other words, the human experiment is done first on the food in a country like India or in Mesopotamia. And then the science is coming only 250 years back. But the food is 1,000, 2,000 years old. So it's tried on many population, it has survived, they have survived, they have been healthy. So therefore, it is very important that not always everything has to be proved by science. We should accept the truth and investigate later on and see how best we can really make it better from the best food we have. To make better than the best is our target in science, rather than ridiculing tradition, wisdom, epidemiology, ancestral knowledge, and say science will do everything. I'm not convinced that this is, unless you prove me by science. It is very wrong approach. Science should come in, but it should also take the best food to a better place. How it can do is what we are interested in. In that, nutrigenomics is a very important word. And in other words, the gene-food interaction today has been shown to be much more categorical, much more medically very responsible than ever before. In other words, the particular gene in a person, familial, inherited by his father, grandfather, grandmother, mother, and so on, has to have something to do with genes in terms of food. In other words, certain families, there is a running of like celiac disease sometimes. So the child also gets the celiac disease. Celiac disease is something, he becomes allergic or she becomes allergic the moment you eat one biscuit. So therefore, immediately to be rushed to hospital, given medical aid and so on. So therefore, how do you really deal with that? Thanks to technology of chemistry and physics today, we can have gluten-free food. We can have foods without gluten or wheat products in it, and the child can still be normal. When all the three brothers are eating roti, the child cannot eat it. What a situation, right? But today, the child can also eat another kind of roti which is identical. It is much more helpful for others to also understand. So therefore, science and technology has come to the help of customers. Then the medically, needed customers today, they don't have to import any food with a cost. Earlier, a lot of imports were there on such things. So therefore, it is very important that we give that importance to food from the point of nutrition. As we move towards another topic, which involves much more chemistry and also fundamental chemistry to the core, is the object of much other molecules in food, such as, you have heard of pharmaceuticals, right? Pharma. You go to a medical shop, it's called pharma shop. You buy a lot of medicine because you are not well, doctor has said. But we have foodaceuticals with the food. We have herbaceuticals from many spices, many herbs and condiments. We have nutraceuticals. Along with nutrition of protein, carbohydrate, fats, vitamins, and minerals, we have other molecules in a food. An apple doesn't give you just these 4 or 5. It gives much more. Ayurvedic, which are much more traditional foods, which have certain bioactive ingredient, which is palliative to some disease, preventive to another disease, curative to another disease, by knowledge of Sushruta Samhita, Charaka Samhita in India. But today, modern medicine, modern science has standardized it so well. It's wonderful to understand what is happening. But how did the ancestors went to that food and called it a medicinal food? And that's because of trial and error. How much of trial and error they must have done. So that distilled knowledge is with us today. And we just say ashwagandha. And ashwagandha is used for many purposes. So the Ayurvedic doctor prescribes. He's also a scientist, please remember. He is not coming from the forest directly. He is a well-trained doctor. When he says something, the modern scientist or the modern doctor has to interact with him. The scientists like us have to interact and come to a conclusion. Hey, this particular medicine, which is ayurvedical, is good for this patient. We should try that first. And his fusion is happening today. And this fusion is a good sign. And it takes a while, to make all people sit together, especially professionals, is very difficult because each one has an ego of himself or herself. So we need to be very careful in how do you fuse this and make it in the right direction. Therefore, the physics of knowledge and the structure of each of the herbal system even goes to the extent of oleoceuticals. Oil is bad, people say, but there are good molecules in oil too. In a limited proportion, it is needed, both MUFA and PUFA, very important for brain growth. Otherwise, you may end up with all kinds of brain diseases at an elderly age. So therefore, we are very important in oleoceuticals, and of course, even zooceuticals have come. In other words, animal health is equally important. One farmer, 4 animals is the key for agriculture. So therefore, his animal health is very important, and those zooceuticals, by giving a holistic approach, not exactly capsules, is so vital. I think it's very important to remember that food is not just protein, carbohydrate, vitamins, fats, and milk. It is beyond that. And let us use that to the maximum extent. Today, there's another factor. I don't want agriculture. I will manufacture the food from the lab. And that's what is food from cell culture. A lot of approaches from the biopsy of that particular animal. If you want to make animals food, from the biopsy of that particular vegetable in terms of its own stem cell, and then calibrate into a nutrition-rich media and make it sure that this artificial cell will give the desired food, whether a meat or a protein molecule, and so on. Today, we are in a very, very different world of pure chemistry and biology mixed to give us the shear. And those sheared molecules can be twisted, can be taped, can be made a strong fiber like a meat, and that's physics. And that gives a meat structure to it, and one can bite and feel. that it still has the same meat kind of a bite. So this is fascinating that without agriculture, you are able to get something from the laboratory, but a long time to go because people have to accept psychologically, people have to accept that. And there is like, give it more time. Don't say everything works in 1 year. Give more time. And that's what is important. In all this, food safety is vital. And whatever you do, unsafe food, you are gone. Because that food is not available to the body. It goes to the alimentary canal and get discharged from the body because the body has a mechanism to throw it out. But at the same time, you also lose a lot of nutrient. So food safety is important. Microbes play a major role. And appartization and canning, first time in the world. Nearly, last century, they attempted it and was successful. And today, of course, we have pesticide, fungicide, herbicides, and also a lot more of, viruses recently in many of the foods. All this means we have a challenge in front of us to give safe food to the society. All food is not safe. It's very important to understand. Looks safe, but it is not safe microbially. It's not safe enzymatically, and so on. So spoilage organisms and fungus can really, especially Aspergillus flavors. And in onion, you have a black powder around like Aspergillus niger, which is so dangerous. So therefore, we have to be very careful in understanding this. And a lot more awareness of public is missing in this area. So food safety is important. Please remember that. To make a food safety work, the world works on each individual country. At a global level of FAO, WHO, we have what is called as Codex, which gives some guidelines. India is a partner to that always. And public must be assured of food safety. It is not my job to make a food safe and pack it. It is the job of the manufacturer to follow that regulation. There is a best before date. Before that, I have to use that. So therefore, it builds up confidence. It builds up a real belief in the system rather than suspicion of the system. It is very important that the regulatory body like FSSA, today, of course, it's more than 10 to 12 years since FSSA is functioning, is doing marvelous job. I congratulate them. But you also see FSSA label in terms of many of these. And the regulations for nutraceuticals was never done in India, neither by any other country. So in 2017, when I chaired that committee and released the regulations for nutraceuticals, the first time in the world, you have to be very careful when you release the regulation for the nutraceuticals, because the whole world is using nutraceutical, more than $500 billion industry. So first time a country releases that regulation of 73 pages. So the rest of the countries had a very easy job to follow that and make sure they add their nutraceuticals into that and make it a document and make it a regulatory document. It doesn't matter. India gives. They're not charging for it. It's a knowledge to be shared. And that's good. More people are safe. More people eat it with confidence. But I want to also warn here the food losses and waste. I think if this talk has any meaning, I would like all of you to hear this very carefully in 1 minute. The amount of food that is wasted by an individual depends upon his psychology. I want to eat less. I don't want to overeat. Whatever, even if it is given free, I don't want to waste it. This philosophy perhaps is very important, because by wasting the food, you are insulting the farmer. You are insulting the Mother Earth. You are insulting your own self, your own family. You are not a role model for your children. So I think it's very important. 10 times you can put a dish, but don't put like a mountain and only eat 70% and throw the remaining 30%. Don't waste food, number one, individual. From an organization point, there are a lot of organizations which takes care of it. From an institutional point, there are a lot of institutions that take care of it, in spite of natural disasters. But the national point, a lot of awareness has come in. And one storage system of one country may not apply to other countries, because the pattern of crop is different, the moisture is different, storage structures are different, the infrastructure is different, and all that adds up. So therefore, it's a wide call I'm making do not waste food at any cost. If you want half a glass of coffee, percolate half a glass. Don't percolate one glass. The reason is how much of effort to grow a coffee seed. It's unbelievable. How much effort the cow makes to give you that milk. Everything gets wasted. So therefore, it's very important. Today, precision engineering, precision agriculture, precision eating also has become a fad. And it's very important, as I talk on this, strategy of market in food is vital when you talk of engineering. Today, high precision engineering, where robotics have come into place, fully armed with physics and engineering, which untouched by food. But the question is, many arguments take place. If we automate everything, will the jobs be lost? So therefore, what India requires is a hybrid. And India is loaded #1 country in the world for small-scale industries, cottage-scale industries, women enterprises, village-scale industries. A puppet making, Lidget, was once a CFTRI process, but the Lidget made it better. So amazing success. So therefore, women power in food industry had the blessing of love and affection to the food. And there is a tremendous opportunity, India being #1. The model of India is carried on to Africa today. A large number of small-scale industries import machines from India, and that gets value added at a very affordable cost. We don't want a super robotic kind of a system and make people unemployed. Yes, in some cases it is needed, maybe 5 to 8%. In some other system where you want a very different approach altogether. But I think in general, we need a hybrid model where it should be semi-automated. And I think that's where the employment increases, the income increases, the quality of life increases, the buying power increases, the affordability increases, the adaptability maintains. So it's unbelievable how a few technology. As I come to the end of the talk, I also want to insist that the capacity building and food for India's leadership is very vital. Today, if Dr. Jeevan Sidhu is sitting in USA, who is working in Saudi Arabia, many times visits India, it's because he was trained in an institution of world renown. And therefore, that kind of capacity building, like example in food technology in CFTRI, has now been spread to all other universities in India. And I'm glad this platform is increasing. So it is our job to create new capacity building. In other words, training youngsters, creating their career, and making them innovative in the system. So capacity building is our job. And if we don't do it, tomorrow will be a vacuum. So we need to build capacity and also good teachers. And teachers who teach must understand it better and be innovative also and involved in research, whatever time they have, because teaching occupies almost 90% of time. Very difficult to find time. But in 10%, you can do a lot. And provided you have a reasonably good laboratory. And nobody would say no when you talk about institution where you can work and be innovative. I want to touch upon today's problem of antimicrobial resistance. Somebody gets hospitalized, lung infection, whatever antibiotic you give, the person cannot survive because antibiotics don't work on him because they're already taken 5 times. Doctor doesn't know that. Crisis. So therefore, many of these antibiotics come from animals, especially from poultry and so on, because they're fed with antibiotics to eat more and become fat, and in turn people eat that. And the antibiotics in the environment, also in the food. So I like the way what Gujarat has done with animals is the homeopathic approach to animal health. So it looks like it's getting into success, but I think it's a very, very different way of looking at it. We have the common feeling that when we talk about food, we invariably say junk food. So never say this after this talk. After this talk, at the most you can say junk diet, but don't say junk food. No food is junk. Is potato a junk food? No. But when you make it French fries, it becomes junk food. How? It's junk diet. You made it fry, it's you. So no food is a junk food. Food is divine. Food is fantastic. And the diet is that's what happens. So it's the diet that is junk, what you make yourself, and not the food. Therefore, it is very, very important to address refined food, highly processed food, and including the example I gave of potato. But the patent aspect of food, many say, I want to do this idli, I want to patent it. I want to do this kind of dosa, I want to patent it. That's not going to work. Food and IPR and patent, geographical appellation, geographical indicators, trademark are very important. India fought vigorously with turmeric and basmati, which we won. We had a very horror time at that time, but we won. But how can we keep on winning every day a battle? So what India did? It stopped fighting. It started filing patents. So today we are on a great platform of patent. So therefore, there are systems which is taking care of that. But on geographical appellation, like mango appellated, GA is there, and lychee is also appellated, and so on. So therefore, there are other trademarks like bhujia, save. All this is in Codex now, because in 1999, we took it to Codex. And Codex mentioned bhujia and save. So therefore, we can do our job. We can protect our country, the traditional knowledge, traditional wisdom, which is fantastic. But I'm not telling we need to add modern science to that to make a fusion. I close my talk by telling the most important point is the gut organism. The gut feeling that I have is the gut organism, which is the gut-brain axis, which controls it today, we know very well. I want to eat a mango, not because of my brain. I want to eat it because my stomach organism, which are 9 trillion in number, are asking me to eat it because they want it. It's not me. So this is very well understood. So therefore, keep them happy. Don't deprive them if they are asking something, but in moderation and mita, moderation. So therefore, keep feeding them. They're your army protecting you. So therefore, never get agitated with them and you pay the penalty later on. I would like to say tomorrow's analysis of IoT, machine learning, AI, will all integrate, converge into funnel and recharge itself into a very, very different mechanism. And that mechanism is yet to see what happens. But in all this, I see tons and tons and tons of food is wasted. In a restaurant, just go around in any commercial restaurant, half of the food is thrown. So please never ever do that and try to bring awareness on that wherever you are, whether you are in an aircraft, you are in a train, you are in a restaurant, wherever you are. I'd like to close with this sentence. Food needs to be really enjoyed. Please remember, it is not to fill up your stomach. Each morsel have to be enjoyed. And the food for the gut and brain connects itself. And that's where wellness comes for this portion. Health is up to this if you say wellness, the happiness, the peace of mind, the equilibrium. So all that comes by enjoyment. And we are grateful to the farmer who grows for us. We are incapable of growing rice by ourselves and eat it. We are incapable. Please remember, you're handicapped to grow rice in your own house and eat it. Somebody else is growing. If he says, I won't give you, you can't have your lunch and dinner. Please be grateful to the farmer and to the Jawan who protects our country to grow our food happily. With an enemy sitting in front of us, can we grow our food? No, we can't. And of course, the agricultural scientists and the food scientists who make all the difference in silently working and giving you the final product. So next time when you see a grain of rice, a wheat flour in your hand, so many people have contributed to that, including the government. And therefore, and of course, the industry, very important, which produces what the customer needs. Thus, food is for all, from pediatrics to geriatrics, and we are grateful to the Mother Earth to use her sustainably is the goal to grow our food and be happy, get the nutritious food, and live 100 years long life on a food-based approach rather than a medicine-based approach. Of course, critical care is medicine, but food is thy medicine if you use it right. Thank you very much. We are on dot at 4 o'clock. I have closed my talk at 55 minutes. Thank you.
Thank you very much, sir. I request attendees and participants, if there are any questions, they can post in the chat box or Q&A, or you can raise your virtual hand. We will unmute you. You can speak. Meanwhile, if any words from Jeevan Sidhu sir, they can speak. they can unmute and they can speak. Sir.
Prakash, thank you very much for such a wonderful talk. I'm so happy to see your smiling face. and I wish you live more than 100 years to give us a knowledge like this in a capsule form, starting from agriculture to processing to nutrition to good health and wellness. Wonderful talk. I really appreciate it. I thought I shouldn't miss it. That's why I woke up early and I listened to you every word.
We are grateful to you, Sidhu. Thank you, Jivan.
Thank you, dear. Thank you very much.
Wonderful, wonderful.
Thank you, sir.
Thank you.
So any other questions, please, you can raise your virtual hand.
I also see Belur Lokesh. He has logged in twice, but since he has logged in twice, at least he can have one question.
Yes,
Okay.
sir. Yes, sir. Yeah, they can unmute and they can speak, sir. Belur Lokesh, sir, and B. Sham Sundar, sir, also. If any words, they can speak. Yes, sir. Sham Sundar, sir, you can unmute, sir.
Sir, it's such a lovely talk to hear you. And the information, what you gave looks so simple, but in reality, it's very complex. And really, we are all blessed to listen to this talk. Thank you very much, sir. That's all I can say.
Thank you. I didn't talk much about fish, Sam Sundar.
No, you did mention about blue revolution, sir.
I just said, grain blue revolution, but there's more to it,
Yeah, exactly.
And the ocean has to be also protected as much as land. Otherwise, we will lose the resource of the 8,222 kilometers of India's coastline. We should be proud, but we are not making use of it fully with the contribution from Professor Ayappan and so on. It's really unbelievable. And Dr. Gupta, our World Food Laureate in India on fisheries. So we have a lot of agenda on fish. People like Sham Sundar, Dr. Ayappan, and Dr. Vijay Gupta have all done a marvelous job to make us self-sufficient in fish and also export of commodities like shrimp in large amount, which has no antibiotics in it. That's the beauty of India. Fantastic. Thank you.
Yes, Nareshji, you can unmute and speak. Thank you, sir. Thank you, Sham Sundar, sir.
Sir, good evening. I have one question, sir.
I'm not sure who is speaking so that I know the
Brahmesh,
name.
Naresh.
Brahmesh from Karnataka.
Brahmesh, okay, please.
Yeah. Sir, we got a green revolution around 1970. So it is a belief that more than advantages we had in the green revolution, we have disadvantages like we have to end up with so many diseases, as you said, antimicrobials and all. So what is the way forward, sir? Like, do we have to really depend on the green revolution or organic farming kind of thing? What is your view on this, sir?
See, when we have plenty, we start finding mistakes. When we are beggars, we don't find mistakes. Okay. So there is a group which always talks negative about positive things. So let us be very clear once. Okay, you grow your own crops. No food is available in the market. Can you grow it, Mr. Naresh, is it?
Yeah.
Yeah. Can you grow it and eat your own food? Tell me in one word. All foods, everything you have to do it yourself because
it is very difficult, sir.
You don't want to believe the agriculturalists, believe the processor. You say chemicals are coming, so I cannot. All diseases are coming to me. I want to go to a village, stay there, grow my own food and nothing else. It's impossible, right? But in a system, when you are driving on the road, you may be a good driver, but there are 100 other bad drivers. Please remember. So therefore, as long as a farmer is aware, he is doing a good job. But there are some bad elements who kind of add all kinds of herbicides, pesticides, and so on. That is all being controlled by regulation. Please remember that. And those regulations, if they are violated, if on the expressway you're supposed to go at 80 kilometers, you go at 120 and kill 5 people and say expressway you can't, you should not drive, you'll die. That's not a good way to say. Regulations are there and violators must be punished. But it's very difficult to punish everybody because most people want quick money and not long-term health. So therefore, it is important to bring awareness, responsibility in the society, and the regulations are available. So I want to, it's a very big question, but I want a quick answer on that is that we are doing well, I'll tell you, compared to many other countries. And therefore, we continue to do that, but bring more awareness, and regulators will be much more cautious. And it should be from our heart that we should not add any contaminant to food by any means, including plastic. Okay, that's our responsibility. I think society, the farmers are very responsible. I'm glad today's farmers are much more, but a few who use as fertilizers and so on. But you can't help it, and that will slowly taper off. But organic cannot give everything in life that you want. Try to go for organic farming. In fact, the way things are grown in India is organic. In Northeast, everything is organic. Nothing is natural. Everything is organic. We have the practice of growing organic. Where is the money for fertilizer? Where is the money for pesticide? Most of our crops are organic. Please remember. But the word organic is defined by trademark of some company who wants to say organic. And so I would not agree on that, even though mix the two, make it moderate, and make sure that we don't comment on green revolution, but accept it with happiness. That yes, we have food to eat today, but that food is not contaminated, let me say. Somewhere in one bag, there may be some problem, but 99%, we are good, we are safe. Let us be positive and positive and positive. Okay, thank you.
Thank you, sir. Thank you so much, sir. Thank you.
Thank you.
Thank you very much, sir.
Thank you.
So there are no questions and no more questions. Now I request our senior scientific officer, Dr. Anand sir, to give some concluding remarks and
I want to express the vote of thanks now. I would like to start with vote of thanks with the slogan Jai Kisan, Jai Jawan. ನಮಗೆ ಅನ್ನವನ್ನು ನೀಡುತ್ತಿರುವ ರೈತರಿಗೆ ಹಾಗೂ ನಮ್ಮನ್ನು ಕಾಯುತ್ತಿರುವ ಸೈನಿಕರಿಗೆ ಇಲ್ಲಿ ಮೊದಲ ಬಾರಿಗೆ ನಮನವನ್ನು ಸಲ್ಲಿಸುತ್ತಾ we are thankful to Dr. V. Prakash sir for delivering an insightful talk on physics of food. I, on behalf of KSTA and on my personal behalf, extend our heartfelt thanks for accepting our invitation to enlighten us on food habits and importance of food processing, nutrition, awareness on food waste, capacity building aspects. I once again thank you, sir.
Thank you, Anand. Bala Santosha. KSTA ಅಂತ ಒಂದು ಆರ್ಗನೈಸೇಷನ್ ಬೇರೆ ದೇಶದಲ್ಲಿ ಎಷ್ಟೋ ಕಡೆ ಇಲ್ಲ. This is a model organization to show how science and technology is given importance for the public and recognition of scientists, recognition of new innovations. ಎಲ್ಲಾನು ಕೂಡ KSTA ಮಾಡ್ತಾ ಬಂದಿದೆ. ಇನ್ನು ಮುಂದೇನು ಅದು ಚೆನ್ನಾಗಿ ಮಾಡ್ಕೊಂಡು ಹೋಗಲಿ, ಅದಕ್ಕೆ ಒಳ್ಳೆ ಪ್ರೋತ್ಸಾಹ ಸಿಗಲಿ ಅಂತ ನಾನು ಹಾರೈಸ್ತಾ, for the entire international community who are present here in this seminar, I would really be very, very grateful for patiently hearing my talk for more than an hour and still not escaping by putting the quit button. I saw all of them who logged in are still there.
Yes, sir.
And that's a good sign, I feel. I think credit should go to KSTA. And for all of you to again say, I'm coming back on November 7th in a different title. So I'm sure KSTA will communicate it. But relatively, I saw less number of people, Anand and Umesh. Circulation has to be more wider, and channel should be different marketing. And I would say we should be having some 5,000 people should log in. Then only country is different. So we need to put effort between now, which is October 30th to November 6th, to make sure the November 7th talk has at least 1,500 people logged in. Then we are doing something different. Otherwise, we have to reach out to people. For example, a short YouTube of 3 minutes of this along with the other one may make a lot of difference. People get interested. So many people don't log in because of various reasons, I understand. Even if a timing has to be changed, yes, we can change. So up to you to decide that. But I just thought I should thank you for the wonderful job you have done. More to do as time comes, and more to make it popular, more to bring awareness. Yeah? Right now, you see, one fellow is selling tomato in front of the house with a mic. See?
Yes, sir. Thank you,
That
sir.
is India. That is India. You know,
Yes.
tomato comes to your door. Amazing, amazing, and fresh tomato. And so therefore, where is the really shortage of food here? Great India. India is wonderful, and love this country. And of course, all other countries together, we should say thanks for the Mother Earth to grow the food for us. If the Mother Earth decides not to grow food,
Yes.
you will go to moon, you will go to Mars, nowhere, nowhere. Protect this earth, to protect your lunch, dinner, and breakfast. Otherwise, it's gone. No chemicals, no plastic. Then only we can survive. But we as food scientists are here to serve the humanity and not for money. Thank you. All the best. May God bless you. Best to KSTA and best to Government of Karnataka. Jai Karnataka and Jai Hind. Thank you.
Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Bye-bye.
On behalf of KSTA and my personal behalf, a special thanks to officers of Minister's Office, especially Dr. Shri Veerbhadraya Hanchinad sir and Shri Rudresh for all their support they extended for this webinar. We are also thankful to students, teachers and professors who have participated in this webinar, and special thanks to my colleagues from KSTA and other DST organizations, and thank you one and all.
Thank you.
Thank you, sir. Thank you, sir. Thank you very much.
Bye.
Bye, sir.
Namaskar.